Every agent story this year has been about the mind. Better models, better memory, better instructions, better ways for an agent to decide what to do. Almost nobody has been working on the boring half of the problem. Where does an agent actually put things? Because the moment an agent stops answering questions and starts doing work, it needs a place to work. Files that survive between sessions, a directory it can list, a shell it can run. And that place has to be somewhere its mistakes can't reach anything of yours. This week, Cloudflare published a repository that is entirely about that problem, and it is the most quietly interesting thing I've read in a month. I pulled the whole thing this morning, the source, the examples, and 19 numbered specification documents, and there are 4 things in it worth your time. The core idea is genuinely strange and takes about 90 seconds to explain. Once it clicks, you'll see why it makes some very hard problems disappear. And it starts from a database, not a disk. There are 3 completely different ways to run code in it. And the difference between them is not performance, it's what kind of thing you're willing to let run. That distinction is the most practically useful part of this repository. They published a benchmark table where their own system loses badly in 1 column, and then 3 rows later quietly beats a real disk. I'll read you both. And there's a sentence in their execution documentation about what happens when a running process outlives its host. That is one of the most honest engineering admissions I've read this year. It explains a limitation by explaining the physics that causes it, which almost nobody bothers to do. Plan, the core idea, the 3 execution modes, the honest numbers, the security question, and who this is actually for. Plus 1 warning that has to come early, because it changes how you should read everything else. All of it from files I pulled and read this morning. Let's go. The warning first, because it's theirs and it's blunt. Before anything else, from their README, close to verbatim, and I'm putting it up front because they did. This package is provided as a preview for feedback only. APIs are unstable, and the design is subject to change. Suitable for experiments, exploration, and prototypes. It is not suitable for production use at this time. And then a second line I appreciated even more. The specification documents in the repository are forward-looking, read them for intent, not as a description of the code today. That's unusually clean labeling. A company shipping a preview, telling you it's a preview, and separately telling you which of its own documents describe the future rather than the present. Most projects blur exactly that line. So everything in this video is a preview, and I'll flag where I'm describing intent rather than shipped behavior. With that established, here's the idea. The core idea, the file system, is a database. Their 1-sentence description, a virtual file system that lives inside a durable object. The durable object holds the authoritative state in SQLite. Unpack that for anyone who doesn't live in that world. A durable object is a small, long-lived server process with a stable identity and its own private storage. You address it by name, it can go to sleep, and when it wakes up, its data is still there. Think of it as an object in the programming sense that happens to be a server. 1 per user, 1 per document, 1 per agent session. And inside it, the files are rows in a SQLite database, not a folder on a disk somewhere. The authoritative version of the file system is a database table. Now, why do that? It sounds like a complication. It removes several categories of problem at once. Persistence stops being a feature. There's no volume to attach, no disk to keep alive, no cleanup job for abandoned directories. The agent's files live where the agent's state lives. Sleep it, wake it a week later, and the working directory is exactly as it was. Consistency stops being a race. The reason concurrent file access is a classic source of pain is that file systems are weak on transactions. A database is not. One authoritative store, with a transactional engine already underneath it, and the whole class of 2 things wrote at once bugs changes shape. And identity becomes trivial. 1 agent session, 1 object, 1 file system, and addressable by name. Not a machine you have to find, a name you already know. The trade is real, and I'll get to it. Databases are not disks, and heavy file work pays for the difference. But look at what this makes free. A working directory that costs nothing when idle, resumes exactly, and can't be confused with anyone else's. For agents specifically, which sit idle most of the time and need to resume perfectly, that's the right shape. And the surface on top is deliberately unremarkable. Their Filesystem interface is described as looking like the standard node file API, read file, write file, make directory, read directory, remove, plus grep, which tells you exactly who it's for. Nobody adds grep to a Filesystem API for humans. You add grep because agents search before they read. 3 ways to run code, and why the difference matters most. Storage is half of it. The other half is running things. And here's where the design gets interesting, because there is 1 function to execute code, and 3 completely different machines behind it. Their words, 1 pluggable execution surface. You call execute, you name a backend, and the same files are underneath all 3. Backend 1, a real container. This one is a genuinely clever trick. The database state is projected into a sandbox container as a real file system mount. using the standard Linux mechanism for user space file systems, spelled FUSE. A small daemon inside the container mounts it, and syncs changes back over a remote procedure channel. The result in their phrasing: full Linux userland, real binaries, real network. So an ordinary program running in that container opens a file with no idea it's talking to a database in a different process. Package managers work, compilers work, anything works. The database is wearing a Filesystem costume, and the disguise is convincing enough to fool every program that's ever been written. Backend 2, a shell without a container. Instead of booting Linux, it runs a bash implementation inside a lightweight isolated worker, and the keyline is that it reaches the authoritative store directly over an internal channel. So, their words: there is no second store and no sync round trip, no container to start, no copy of the data to reconcile, just a shell, talking straight to the truth. Backend 3, JavaScript in a fresh isolate, with structured input and results, durable relative imports, the standard node file API wired to the workspace, and specific trusted modules for source control and publishing. Now why 3? It looks like indecision until you notice what actually varies, and it isn't speed, it's what you're willing to let run. The container is the most capable and the most permissive. Real processes, real network, arbitrary binaries. The isolate shell is narrower, no container, so a much smaller surface. The JavaScript isolate is narrowest of all, a defined module, structured results, an explicit allow list of what it can import. That's a capability ladder. And for agents, it's exactly the right control, because agent tasks vary enormously in how much trust they deserve. Transform some text. Your agent already has, that's the narrow rung, and you should use it. Compile a project and run its tests. You need the full container, and you should think about it first. The instinct this repository encodes, and I think it's correct, the amount of machine you hand an agent should match the task, not the maximum you own. Most agent platforms give you one environment, and it's always the most powerful one. This gives you a dial. Two smaller details that show taste: backends connect lazily on first use. So a session that only reads files never pays to start a container. And the workspace can be constructed with no execution backend at all, giving you just the file system. That's the humility to admit a lot of agents need storage and no shell whatsoever, which is true and rarely offered. The benchmark table where they publish their own losses. Now, the part that decided my opinion of this repository. Buried at document 19 is a performance page, and it does the thing almost no vendor does. It benchmarks the new system against the two obvious alternatives: an in-memory file system and a real disk, and publishes every row, including the embarrassing ones. The workload isn't a toy either. Alongside their own file benchmarks, they ran a full package install of a real project. 854 packages over 36,000 files. Deliberately the worst case for this design. Here's the first row, and it's brutal. Creating 1,000 files about 560 milliseconds against 83 on an in-memory file system. Almost 7 times slower. Against a real disk, it's still nearly twice as slow. If they'd stopped publishing there, you'd conclude this is a nice idea with a heavy tax. But keep reading down the table, because 3 rows later, it does something I didn't expect. Removing 1,000 files about 828 milliseconds against the real disk's 1,282. Their system is faster, about a third faster. Building a directory tree, 10 by 10 by 10, roughly 1,600 milliseconds against the disk's 3,000. Again, faster, about a quarter quicker. And checking the status of 1,000 files, slightly faster than the disk too. So the honest summary is not it's slower. It's creating many new files is expensive, and operating on files that already exist is competitive with, sometimes better than an actual disk, which makes complete sense once you remember what's underneath. Creating a file means inserting a row and paying for durability. Listing, checking, and deleting are things databases have been optimizing for 50 years. And they tell you the practical consequence themselves in the limits section. Aim for agent-scale workspaces, not full monorepos, and expect heavy work, big installs, large archive extractions to be slower than native disk. They also publish the ceiling, roughly 10 gigabytes per workspace, shared with the object storage. Published limits, published losses, published worst-case workload. I've spent this year reading vendor benchmarks that are shaped entirely by what the vendor wanted you to conclude. This one hands you the number that argues against it in a table with the baselines named. That's the behavior that earns trust, and it should be normal rather than notable. The sentence about restarts. Now the engineering admission I flagged from the code execution document. It concerns what happens if a running process outlives the thing that started it, and it's close to verbatim. An execution left running across a host restart is reconciled to failed because a live capability cannot be serialized into the database. I love this sentence, and here's why it's worth 20 seconds of your life. Most software would document that as a bullet point. Running executions do not survive restarts. Fine, accurate, and it teaches you nothing. This version explains the cause. The handle to a running process is a live thing, and live things cannot be turned into rows in a table. Everything else in this system is durable because it's stored in a database. A running process cannot be stored in a database. Therefore, it cannot be durable. That's not a limitation they chose, it's a boundary of the approach stated as one, and it tells you something general about this entire category. State can be made durable, activity cannot. Any agent platform promising that both survive a restart is either doing something very clever or something not quite true. They're consistent about it too. The same document notes that the lightweight shell backend runs to completion, keeps no cross-request events, and cannot be reattached, and then says plainly that callers who need supervised process behavior should use the container instead. Here's the limitation. Here's the alternative, in the same paragraph. That's how you write documentation. What's already built on top, and the agent batteries. Worth knowing what ships alongside because it tells you how seriously this is aimed at agents rather than at developers generally. The package includes what their README calls batteries for agents, ready-made tools for the popular AI toolkit, read, write, edit, list, execute, a Git client, read-only mounts backed by object storage, and helpers for publishing files. Look at that list as a design statement. Read, write, edit, list, execute is the complete toolset of a coding agent, and it's shipped pre-wired to the file system rather than left as an exercise. The Git client matters more than it sounds. An agent that can commit has an undo history, a diff you can review, and a way to hand work back to a human. Version control is the cheapest safety mechanism in agent work, and building it into the workspace rather than bolting it on afterwards is the right instinct. The read-only mounts are the quieter idea, and I like them a lot. A workspace can have material, it can read, but cannot change. Reference documents, a dataset, a corpus, sitting alongside the space where it works. That's a permissions boundary inside the working directory itself, and it maps exactly onto how agents actually operate. Lots of input to consult, a small area to modify. The examples folder is worth opening too. Alongside the 3 backend demonstrations, there's a chat agent that uses the workspace as its working directory, reachable from a terminal, and the one I'd read first, an example that runs the same agent against different runtimes, so you can compare them. That's a repository that expects you to test its own trade-offs rather than take its word for them. And a small detail that made me smile. The repository ships an instructions file for coding agents. The same convention we watched the whole ecosystem converge on this year. A project explaining itself to the agents that will work on it. Infrastructure for agents, documented for agents. That's either very neat or slightly recursive depending on your mood. The security question, what this is and isn't. The obvious question for anything called a sandbox. Does this protect you from your agent? The honest answer from what I read is partly, and by construction, rather than by promise. The strongest property is the latter. If you run a task in the JavaScript isolate, it gets a defined module with structured results and a specific set of trusted imports. That's a genuinely narrow surface. The lightweight shell is broader but still has no container beneath it. The full container is the widest, and their own description says the quiet part. Real binaries, real network. That's the point of it, and it's also the boundary of any comfort you should take. The second real property is blast radius by design. A workspace is scoped to its object. One session, one file system, one identity. An agent that ruins its workspace has ruined a workspace. Not a shared machine, not other users' data, not your laptop. Compare that with the pattern we keep seeing in local agent tooling, where the agent runs as you, with your permissions on your actual machine. This is a meaningfully better shape for the same work. And the third thing to understand, choosing correctly is your job. The system gives you 3 rungs, it does not decide which rung a task deserves. That decision is yours. On every task, and the temptation to always use the most capable backend because it always works is exactly the temptation to design against. The rule I'd take, pick the narrowest backend the task can survive in. If a job only transforms data your agent already has, it does not need a Linux userland. Most agent tasks don't. Who's paying and what it tells you. Standing rule. When infrastructure this considered is published free and MIT, find the invoice. It's not hidden here, and it isn't complicated. This runs on their platform. Durable objects, containers, workers, object storage, the components are theirs, and code written against this runs where those components live. The library is a gift, the substrate is the business. That's the 4th flavor of free we mapped out recently. The open thing exists to make the paid layer more valuable, and it's the mildest of the 4 because the incentives point at making the free part genuinely excellent rather than deliberately limited. The portability question is still worth asking honestly. The concepts here, a database-backed file system, projecting state into a container, a capability ladder for execution are transferable to anything. A specific implementation built on one company's primitives is not. MIT means you can read every line and take the ideas. It does not mean this code runs elsewhere. And the strategic read is more interesting than the commercial one. Look at what's been assembled. An agent needs a mind, knowledge, and somewhere to act. This week alone, we've watched the mind layer commoditize, the knowledge layer standardize into shared formats and marketplaces, and now a serious infrastructure company treating the third layer as the interesting problem. Whoever makes somewhere for an agent to safely do things boring and cheap will matter more than most people currently expect. Should you care? 4 honest cases. Analysis is only useful if it turns into a decision. So here's mine. 4 ways. If you're building an agent product today, read this repository, don't deploy it. It's a preview, and they say so. But the design is instructive whatever you build on. The database-backed working directory, the capability ladder, the lazy backend connection. Those ideas are portable to any stack, and this is the clearest published articulation of them I've seen. If you're running agents on your own machine right now, this is the contrast that should bother you slightly. Your local agent almost certainly runs as you. With your permissions in your real directories, the tooling we've read this year says so in its own warnings. The shape here is better for the same work. An isolated workspace with a chosen amount of machine. You may not want to move to somebody's cloud to get it, and that's legitimate, but the shape is worth stealing locally, with containers and disposable clones. If you already build on this platform, this is straightforwardly good news and the easiest experiment on the list. The primitives are ones you already pay for, the library is MIT, the examples are runnable. The only real question is whether your workloads fit the published limits agent scale, not repository scale, and their benchmark table answers that faster than any trial would. And if you're just trying to understand where agents go next, this is the piece that's been missing from the public conversation. Everyone has been arguing about models. Almost nobody has been publishing serious thinking about the runtime an agent inhabits. Durable state, scoped identity, graduated permissions, honest failure modes. This week, one company put 19 specification documents about it on the internet under a permissive license. That's the story, regardless of whether this specific preview becomes the thing that wins. Honest limits. 5. 1. And it dominates. This is a preview by their own declaration, explicitly not for production. Everything I've described could change. Read it to learn. Prototype with it happily, and don't build a business on it this month. 2. I read the repository, not the running system. Source, docs, examples, benchmark tables, read, deployed and load tested by me. No. The performance numbers are theirs on their hardware and unusually well specified, but they're still self-published. 3. The specification documents describe intent. They label this themselves. Several files describe planned behavior, marked inline. When I described capabilities, I stuck to the shipped README and package documentation, but if you read the spec folder, read the markers. 4. The limits are real and specific. Around 10 gigabytes per workspace, container-side file system held in memory, heavy input and output slower than native disk. Agent scale, not repository scale. They say it plainly, and so should I. 5. It's platform-bound. Not a criticism, a fact to plan around. Step back, because this repository is a small answer to a big question. For 2 years, agent development has been an argument about intelligence. This week, the picture completed itself in a way I don't think anyone planned. The mind became something you swap, a parameter, not a purchase. Knowledge became a file format, skills, plain markdown, shared directories, now marketplaces. And here, quietly, the third piece, a body. Somewhere to keep things, somewhere to act, and a dial for how much machine the task deserves. The idea underneath is the one I'll keep. Make the file system a database, and durability stops being an operational problem and becomes a property. No volumes, no cleanup, no lost work, no ambiguity about whose directory this is. You pay for it in file creation speed. They published exactly how much, and for the workloads agents actually have, the trade looks good. And the meta lesson from reading it. The trustworthy documents are the ones that argue against themselves. A benchmark table with losing rows, a limits section with real numbers, an explanation of why something can't survive a restart instead of a bullet saying it doesn't. A preview labeled as a preview with its own specification marked forward-looking. None of that is required, all of it is signal. When you're deciding what to build on, that's worth more than any feature list. So here's my question, and I'll pin it below. Where does your agent actually put its files right now? Not the model, not the prompts, the files. A temp directory that vanishes, your real home folder with your real permissions, a container you rebuild each time. Most people have never made that decision deliberately, which means the answer is whatever the tool defaulted to. Tell me yours, and whether you'd trust it with a task you weren't watching. That single question separates people running demos from people running agents. Every link, the repository, the exact performance document, the execution and mount specifications, and our full breakdowns of the mind and knowledge layers this fits between, is in the description. Read the benchmark table, losing rows and all. That's the standard here, the real design from the actual files in plain English with the trade-offs named and the credit given. If you'd rather own your tools than rent them, subscribe. That's what we do every single day. I'll see you in the next one.